And next up, we've got Merritt Jenkins, who's a summer associate here at LDV. Merritt's going into his second year at MIT Sloan School of Business for his MBA. He has a master's in robotics from CMU and over 8 years of experience deploying robot hardware and vision systems in harsh environments with startups like Plenty and Pattern Ag, which he co-founded. So Merritt's going to be showcasing some of our findings related to the top opportunities for automation in meat processing.
Thank you, Abby. As Abby mentioned, I'll cover opportunities for machine vision in meat processing and also describe how COVID is accelerating adoption. As you've likely read in the news, a high number of outbreaks have occurred in meat processing plants. And the CDC recently reported that almost 1 in 10 meat processing workers tested positive for COVID. These outbreaks are a risk to employee retention, they're motivating strikes, and they're also inviting greater regulatory scrutiny. But many of the underlying labor issues are not new. Labor turnover has been a significant issue for years. It ranges from 40 to 70%, while the average for the manufacturing industry is about 31%. The industry also relies heavily on immigration. About 1/3 of the workforce consists of foreign-born non-citizens. And the domestic meat processing industry is big. It generated $230 billion in revenue last year and employs over 500,000 people. The major players are committing to upgrades. JBS, the largest processor of beef and pork, committed to $1 billion in capital expenditure in the US this year. And these upgrades are starting from a low baseline. For example, Tyson just announced that they're installing cameras for inventory tracking to replace what was traditionally hand signals. So what do I mean by meat processing? I'm specifically referring to fabrication plants in which live animals enter one end and packaged, deboned meat exits the other end. So depicted here is a floor plan of a chicken processing plant. There's variation across different types of animals, but the general steps are the same. On the left side, live animals enter the facility. They're then stunned, killed, defeathered or skinned, eviscerated, chilled, cut up, deboned, inspected, and then packaged. The red dots throughout the floor plan show where people are positioned. All of these manual processes will benefit from machine vision and robotics someday. In the rest of the presentation, I'm going to concentrate on 3 steps: cut up, deboning, and inspection, because they have the highest density of workers and they're also the most active areas of research. So within these 3 steps are several opportunities for machine vision. One opportunity is to automate what are called primal cuts. This is the first step in breaking large carcasses down into smaller pieces, and automating these large cuts can improve yield. The technologies used here include 3D scanning with structured light and dual energy X-ray absorptiometry, which uses 2 X-ray sources that enable detection of not only bones, but also fat and muscle to improve the cut location. There is also opportunity in deboning. The majority of deboning is performed by hand in the US, and 2D X-ray combined with GPU computing enables some tasks, such as thigh and leg deboning, to be automated. And camera-based inspection for quality assurance has been around for a while, but cloud computing to run neural nets is still actually gaining adoption. Also, 2D X-ray imagery is becoming more common to detect the presence of bone fragments in meats. There's opportunity for this information to also evaluate the quality of output from individual employees and pay based on performance. So it's challenging to outline exactly what the adoption curve will look like for machine vision in meat processing, because there are many variables. For example, floor space is highly valued because facilities need to be refrigerated. So the footprint of automation equipment is a critical factor. Other examples include access to labor, that's a function of geography, yield economics, which is a function of meat value. You've got local legislation, you've got variation in animal size, and also reliability of equipment. Two benefits of machine vision in meat processing include automating dangerous and repetitive tasks and capturing data that enables animal breeders and farmers to grow healthier, higher yielding animals. So I'll conclude with the importance of machine vision and automation to industry competitiveness. The combination of wage pressure, labor turnover, and employee health risks means that this industry now has the appetite to change how it approaches traditionally laborious tasks. Thank you.